Okay. Yeah, guys, do you guys have any question from yesterday's class? Okay, fine. So, we have seen what is big data yesterday and what is the problem associated with the big data to process, to store and manage in traditional approach, right? So, we'll be going to look at what is the solution, how we will solve that problem using Hadoop. As we know that Hadoop is a framework which is designed and developed by using Java, and it has been introduced by, it has been developed by duck cutting. So it is in 2006. So we have seen history also yesterday, right? 1 second, guys. I'm getting some disturbance from others. So I'll just make. Yeah, fine. So it has been developed by duck cutting in 2006, right? So how it will solve the problem? What is the approach it is following? What are the features are there with Hadoop, and how it works in the big data, right? So as I said, Hadoop is an open source Java based framework that allow you to store a huge amount of data and where we can process it parallelly in a big cluster in the commodity hardware. Okay, here what is a cluster? Cluster is a collection of data nodes, collection of computers. And what is a commodity hardware? Commodity hardware means which is a cheaper hardware. So no need to maintain a high-end servers, data servers I can say, where we'll store the data and process. When it comes to the Hadoop, it will work on commodity hardwares, cheaper hardwares like RAM can be 64 GB or 128 GB, and the hard disk will be 1 TB, and processor will be 8 core or 16 core, 32 core CPU. With respect of the organizations, with point of organization, these are the cheaper hardware compared to buying a new bigger servers. Right, then how it will solve the problem? Before going to look at the how it will solve the problem, we'll see what are the futures are associated with the big data. Okay, this has a history we have seen yesterday. So when it has been introduced and how it has been introduced. Okay, so why we need Hadoop and what is the features of it? In traditional approach system, to store a huge amount of data, we have to replace an existing system with a high-end machines, where which is expensive. And to process the data, we need to buy some ETL tools, which are licensed. And we have to maintain a big server. After processing the data using ETL, we have to maintain a big server where we'll store the processed data into databases, right? Those systems should be the high-end machines. And if those machines are, the data will be stored in a single machine or network file systems. If any one of the machine is failed, we may not able to recover there, and there is no data locality available in the traditional approach system. And if uh, it is not allow the parallel processing. When it comes to the Hadoop, it is a cost effective, where it's a open source where you can download and start using that. There is no need to pay for license. And as I said, it's to work on the commodity hardware. Right? So there is no much cost involved on this Hadoop framework. We'll see how it will work under. We'll see the architecture. I'll show you how it will form the cluster and all. We'll see. Before getting that, we are seeing what is the features of it, and it's a scalable. It can be processed a huge amount of the data in a parallel fashion. It's a distributed. The data has been distributed across multiple machines, where when you want to process a data, it will be processed in parallelly in a multiple machines. So because of parallel processing, we are achieving the results in a quicker, or I can say in this less time. And also, as I said, it's open source. The speed of execution is fast, and you can recover the data. It's a fault tolerant. I can say it's a fault tolerant. And if you keep your data is keep growing, you don't need to replace the existing system. You can just go ahead and buy another commodity hardware where you can add to the existing cluster. Is this clear, guys, about the future of Hadoop? Any doubts? May I go ahead? Yeah.
Ravi, sorry, here I have a question.
Yeah.
So when we compare with a traditional ETL tools,
Okay.
so you said like after processing the data,
Mm-hmm.
so you said that to store the processing data, we need a server, right?
Yes, correct.
So here I'm trying to understand, like
Mm-hmm.
after processing the data,
Mm-hmm.
I can say now I will use the word as a target. So how the target capex will be different in Hadoop and a traditional ETL?
Okay. So
Because uh, yeah, go ahead, Ravi.
okay, in a traditional approach, once the data is generated by the sources, the data will be raw data, right? So that from the raw
Mhm,
data, we'll use some ETL tools like Ab initio, Informatica. There are some other ETL tools where we'll extract
mhm,
the valuable information,
mhm.
and that valuable information we will store in some RDBMS, traditional machines,
Yeah,
RDBMS
yeah,
systems. And if
yeah.
let's assume after processing the data, you are getting the TBs of
Mhm.
data, huge amount of
Yes,
the data,
yeah, yeah.
and that data when you query from your client machine or same from the your storage network area machine, what will happen? The first thing is when the huge amount of data is getting processed and huge amount of data is being generated, that data has to be stored in the RDBMS after processing. And
Yep.
when you issue a query or when you want to process in the sense access the read the data from the database, what will happen? We are missing the data locality. Like we are getting the data from the RDBM system, the client machine, where it will process, where it will execute, right? The query.
Hmm.
After
Okay.
processing the data is then some data centers in the network file system. I have issued a command. So when I issue a command, what it will do, it will try to get the data to local machine,
Okay.
and it will get and store into the client machine's main memory, where it will execute and where it will apply the business logic or computation, I can say.
Okay.
Let me explain in this way.
But already why the competition again? Because like we already like let us consider I have a, one of the business requirement.
Okay.
So as for the business requirement, I took the data from source.
Okay.
So I already processed that. I already loaded in the target.
Okay.
So from the target, what I do is based upon my like again the target also that I can say that is a data
Mm-hmm.
because source is the metadata and sorry source is the data and target is the metadata based upon the requirement.
Okay.
So on the target, we will be querying for some purpose, but like after target, that operation should be the same in Hadoop also, right?
The target will not be RDBMS system, right? The target will be on top of in Hadoop only, in HDFS file system only, right? It not be a different one.
Oh, okay. You mean to say that means in a traditional ETL, we
Mm-hmm.
still need to spend.
Yeah, I'm just trying to draw a diagram here. If you try to correlate. Rama, your voice is breaking. I'm not able to hear you properly. Let me explain in
Oh,
this
is it?
way. Yeah, now it's clear. Okay.
Okay.
So, are you able to see my screen here, Rama?
Yeah, yeah.
Okay. So, see, these are the sources like your financial institutes or social network where the data will be generated.
Mm-hmm.
Okay, and we will use the some ETL2 to process it, right?
Yes. Yeah.
After processing the data, where we'll store into RDBMS. I mean, some database.
Yes.
So
Yeah.
this is an external source. This target, as you
Yes.
said, this target is a different machine,
That's right.
which can be NFS, network file system, and let's assume it has a huge amount of the data after processing it, cleaning up.
Okay.
So when I query from here, so what will
Okay.
happen? The data has to be traversed through network to get into the client main memory.
Okay.
I mean, the computation will happen in main memory, right?
Got it. Okay. Okay.
So let's assume which is a 10 GB of data. So the 10 GB data has to be traversed through a network,
Mm-hmm.
and it may take some time. Let's assume it's 30 minutes it's have taken.
Mm-hmm.
And when I apply the computation, again the computation will take some time. For downloading, I
Mm-hmm.
mean, getting the data will take some time, and processing data also will take some time. Let's assume it's taken 15
Okay.
minutes. Total,
Okay.
I'm taking 45 minutes to process this,
To get the report from
to get
now.
the report. And with a high-end processor,
Uh-huh.
right? And also the time consuming, right? Let's assume, okay,
Okay.
10 TB, okay, here it has stored 1 TB data.
Mm-hmm.
Please bear with me, guys. This is a new tool for me. I'm just started using it. Okay, so
Otherwise, Ravi, I think maybe Paint would be faster. I think.
I mean, the mouse, I'm not that much comfortable with that.
Oh, okay. Okay.
Okay,
Okay.
so here in the database, I have stored 1 TB data,
Uh-huh.
and it's worked well.
Okay.
And my users are increasing. My data is getting increased. It became a 10 TB.
Mm-hmm. Mm-hmm.
Again, I need to replace this existing system. I need to buy a bigger servers,
Maybe add one slot. Okay.
right? So it's
Okay.
expensive. It's an expensive. And when a computation, it 10 GB I'm retrieving presently. I may retrieve for the last 1 year or last few months. So it may again increase to 20 GB or 15 GB. Again, it'll time taking while traversing the data, and processing also will increase. And here I have
Mm-hmm.
to invest something for my uh, tools, for retail tools.
Mm-hmm.
So which is costly, and for not it's not a fault tolerant. If any one of the machine is failed here, even though we are in NFS, it's connected to multiple machines, but specific data will go and store in one machine only. And if that machine is failed, we
Okay.
may not be able to retrieve the data. It's not a fault tolerant,
Okay. Mm-hmm.
and time consuming as well. And if I want, data is growing, as well as my investment also on hardware also is getting increased.
Yeah. Then how it will be different in Hadoop.
Yeah. So when it comes to the
Yeah.
Hadoop, yeah.
Why I'm asking is,
Mm-hmm,
so such scenario,
mm-hmm.
the same thing actually.
Okay.
So this is a real-time scenario that we faced recently.
Okay.
Actually, in my application,
Mm-hmm.
so we have one of the SQL server.
Okay.
The SQL server has been used by two applications.
Okay.
What was happened was when initially, it's 3 years ago,
Mm-hmm.
when the architect he designed about the database, he did not expect like this much memory,
Data.
a large amount of data.
Mm.
Now suddenly, what was happened was,
Mm-hmm.
so our servers went out of memory.
Okay.
As a temporary solution, what we
Mm-hmm.
did was,
Mm-hmm.
so like we invested the amount to
Okay.
double the size by ordering the extra hardware, like
Correct.
extra hard disks.
Hard disk. Correct.
So now actually, infrastructure team,
Mm-hmm.
they already double the size by installing a additional hardware.
Mm-hmm.
That doesn't mean that solve our requirement,
No, it will not solve.
because so because presently my application has been used by only 10 users,
Mm.
but we have 200 dedicated users. They have not started using yet.
Correct.
So that's the reason what I did was I took a call.
Mm-hmm.
Again, we did some initial analysis.
Mm-hmm.
Then finally we are moving to cloud,
Correct.
because cloud, when users started using it, it will automatically get extended.
Correct.
So I actually personally faced this issue recently.
Okay. And also here, when you increase the only hard disk, it may not be able to solve your problem. So you have to increase your
Yes, I have increased the RAM also.
yeah
I have increased the
process
RAM also.
processor, and how many cores you are using. So whether the
That's why.
data is parallelly processing or single machine only processing, all this will come into picture.
Yes, partitions. Again, partitions also we have to take care of it.
Correct.
Yes.
So
Yes.
when it comes to the when it comes to the Hadoop, if your data is getting increased, you will not
Mhm.
see what you will do. You'll just add on machine, one extra machine in the cluster. Like I'll come to that point.
Okay.
I'll come to that architecture actually.
Okay, maybe I think, but during that, because here, because maybe I don't want to take much time on it because maybe anyhow you will be covering it.
Yeah.
So my question is
Mhm.
the ecosystem, because that's where I have one doubt actually.
Okay.
When you when you install because the Hadoop is a mixture of MR, HDFS, and ecosystem.
Correct.
So will it be available on each cluster, like on each node, on cluster node?
Could you please repeat your question? His voice was broken.
Because like
Yep.
when we install a Hadoop,
Mhm.
it will come with ecosystem also. It
Correct.
will come with EMR, it will come up with HDFS.
Correct.
Because I know there are some data warehousing tools within the part of ecosystem, just like a Hive and HBase.
Correct.
When like now when my data getting increased, I added one more cluster. So when I set the cluster, this is a data node.
You have one more data node. Correct.
Yes,
Mm.
cluster means so here is a data node.
Mm.
So when I add a data node, will that come again with one more Hive database?
Yes, obviously. See, all these machines will treat as a single file system.
Okay.
What are the data nodes we are adding? All will treat it as
Mhm.
a one single namespace. Ideally, I can say that namespace will
Okay.
be maintained by your name node.
Yes.
So when you add a new machine, it is for that. It is a new space you have added, and you have added new processor for that, and you have added new core for that. How many cores that machine has? And
Okay.
what it do when you store the data, when data is getting increased, there are some blocks of data will go and sit in that machine, right? Some blocks.
Got it. Okay. Got it.
Yeah. When
Okay.
you want to process, when you process the data, here what we have to think in this way, like the data is storing in the blocks.
Mhm.
This is a block structure database. I mean, block structure data file system. Here, the data will be divided into the blocks, 64 MB chunk of data, or it can be 128 MB. That data will be spread across the cluster. Cluster in the sense here, collection of data nodes, small, some commodity hardware. So
Okay.
let's assume if you take 1 GB data, it has been broken into 16 parts. That 16 parts will be stored across the multiple machines, not in the one machine. Okay, these 16 blocks of the data will be processed parallelly by my
Okay.
whatever the computation I will be sending. That computation will be executing on all independent machines wherever the data is available.
Okay.
So where we are achieving the parallel processing, where we're reducing the time to process whole data. And when it comes to storing part, yes, you just add a new node, or you just add a new data node. Your name node will spread the data. If the data is getting increased, what we will do, will not just add one data node, or will be adding couple of data nodes, which are the commodity hardwares, and your data will be
Mhm.
storing across the cluster, right? It is not in one place. It will be in multiple places.
Okay. Here is the question, Ravi. Because now the processed data, like now I have a data across individual data nodes.
Hmm.
So after processing, so the processed output, that means the final output,
Mm.
that means my value.
Mm.
My value, will it be stored on the same data nodes, or the output from the individual data nodes will be stored in a single database
No, it will be stored in all the data nodes. Again, it's how much big the
in
output
each
is.
data node?
Yes.
So that okay. Then if it is storing on individual data nodes,
Hmm.
if I wanted to run a report,
Okay.
so how can I run a report? Like I have a 10 data nodes.
Okay.
Then each data node has a processed data in this, like maybe Hive database, maybe HBase database.
Okay. I mean, Hive is
Like
database system, and HBase is our database actually.
data, yeah, database system, yeah. Now, so after that,
Mm.
like now I have a data on 10 nodes.
Okay.
Now I want to run a report. But my report, in the report, I want a final output.
Okay.
So that will come the data from all the data nodes.
Correct. Parallelly. And at backend, again, it's a MapReduce job will be launched, and it will start retrieving all the data.
No. Why MapReduce will come into picture? Because I am talking about the final output.
Even final output, the data, see, you process in the sense what you have processed. What is the
I
process?
already processed. Like let us consider the reducer. Reducer already gave me a final output.
Okay, that data will, okay, that is also stored in the HDFS. Okay.
Yes, that also stored in HDFS. That's my question. Like the data that comes from reducer, will it store on individual data nodes or will it store in a single database?
No, it will not store in a single database. That is for sure. It will store in the whole cluster, in individual data nodes. Okay, when you
Okay,
retrieve.
now like if I want,
Okay,
yeah,
see, I
go ahead,
think.
Ravi.
Okay, let me put in this way, Rama. What we are doing here, the data will be stored in the
Mm-hmm.
multiple machines, and which is the raw
Yes.
data, and I have processed it
Mm-hmm.
by using
Yes.
some logic. I have implemented some computation.
Got
I
it.
have
Yes.
taken the processed, and the
Now I
process.
got the value. Yes.
Now we got the output. I mean output value. What we will do that it
Yes.
will be there in HDFS only. It will be there in HDFS and
Yes.
multiple machines. Okay,
Yes.
so when you want to store it in a single database, I mean database, like it's a database form. What we will do,
Mm-hmm.
if it is a MapReduce processor data, we need to use some
Mm-hmm.
queries to
Mm-hmm.
retrieve the data and store into HDFS, or sorry, in a your HBase,
Data.
it's
Yes. Okay.
which is an output. Because to write the queries, where will write the queries, through HBase or through Hive? We have to write the queries.
Yes.
That output, whatever the output we are getting, will put into the HBase. Again,
But
the
is that the headspace? Is the headspace is again a individual entity on individual machine, or is a one single machine?
it's a multiple machines, not in a single machine.
Like if I wanted to query, I need to connect to the all the servers, right?
Yes. When you query again on top,
If I want.
when you scan the HBase, it will be get
Mhm.
scanned parallelly. We'll see that. I'll show you the architecture. No, it
Yeah,
is.
yeah. Maybe too early. I think maybe
Yes.
that is a too early. Yeah. Sure, Ravi.
Okay. Yeah. Okay. So go back to our thing. Okay. What is the features of Hadoop? Okay. Actually, we went out of the current thing. So the features of Hadoop is cost effective, scalable, and open source. As we said, it's a speed execution because it's a parallel processing. Then we'll see one by one each feature. What is a cost effective system? As I said, your Hadoop or Hadoop cluster does not require expensive or specialized hardware, where we will install our Hadoop or our framework on the commodity hardware system. Commodity hardware system, as I said, it is a cheaper hardware, right? So instead of investing on the bigger machine, the specialized hardware, we will invest the same thing in multiple machines, where we'll get the more performance and where we'll get the more, uh, I can say more performance, and it's a large cluster of nodes. It means that multiple clusters. Yeah, even if you, as I said, if your data is going to grow, data is getting growing, and we can simply go ahead and store the data nodes. I mean, we can store, just install a new data nodes. I'll show you that architecture, how it looks. Then you will easily understand. Okay, so how the Hadoop architecture looks, I just give a brief small diagram. It is work on the master slave architecture. One guy will be master and who will be managing the cluster, and one guy will be who is a slave who will be storing the data and who will be actual processing the data. Okay, the master will call as a name node, and slaves we call as a data nodes. When your data is getting increased, what we will do, we'll add one more data node here. You can go ahead and increase, and your name node will keep managing the data nodes. The commodity hardware, what I was talking about, these data nodes. If your data increase, you just go ahead and add one more data node. You don't need to go for the special hardware. Okay. and it's a large number of clusters. These data nodes can be any number of data nodes. I mean, it can be any number of machines. It can keep increase, depends on the business requirement, depends on the data is getting generated. You can go ahead and keep increase these data nodes. Okay, yeah, and it's a parallel processing. Sorry, parallel processing. Here, as I shown in the diagram, the data is getting stored in the multiple machines. When I issue a command, the data will get processed here, and the same data will get processed here, and the same data will get processed here. Let's assume I have one file which has a 1 GB data, and my data will store in the cluster in the form of blocks. I'll come to that point. Let's assume it will generate 64 blocks, and the whole 1 GB data will be stored in the distributed manner. Means the 64 1 GB data will be some part of the data will come here on 64 MB, and here like that it will be stored across the cluster. Depends on, there are some policies, we look at them. And when I issue a query or when I issue a competition to process my data, the, the independently the data will execute here. I mean, the data will process here, and it will get processed here as well, and it will get processed here as well. So what is happening? The same 1 GB file is getting processed and broken into pieces. So divide and conquer. It's like a divide and conquer. So the data is getting processed in individual machines. The output will be generated fastly, and the final output will be clubbed together. We'll see that process also, how it is getting clubbed and how will it's getting generated. Though that is a parallel processing. Instead of processing the whole data, 1 GB data in the single machine, we are processing into multiple machines. Instead of processing in one single machine, which will take some time, instead of that, the same data you divide into multiple pieces and store in the whole cluster, you start processing them. Okay, clear about the parallel processing? Okay, so to achieve the parallel processing, the data has to be distributed across the multiple machines. Then only we can achieve the parallel processing. In Hadoop, whatever the data you store, whatever the data is coming to Hadoop cluster, the data will be spread across the multiple machines. It means spread across the cluster. Here Hadoop is following block structure file system. I mean, even the normal file system also is block structure. And when it comes to Linux, it's a 4 KB block. When it comes to the Hadoop, it's a bigger block. We'll see them, we'll see them going forward. And there is a one more beautiful feature from Hadoop is that automatic failover. Let's assume I have stored the data in multiple machines, and one of the data is failed. This data is failed. It's okay. We no need to worry about it, because while storing the data, the Hadoop by default it will replicate the same data into 3 different machines. So even though if it is failed, we are not going to lose any data because there are another 2 replications. So when we get a new machine and inserted in the cluster or added to the cluster, the data will be again balanced properly. We'll see those things, how the balancing will run all these commands. I mean, how to run and all this we'll be looking at. Okay, that is a automatic failure. When the data is node is failure, no need to worry. We're not going to lose any data. We can easily replace that particular machine, and we're not going to lose any data in that. Clear about this? I'm moving to next slide. Okay, data locality optimization. This is the best feature of, I can say, one of the best feature in the feature in Hadoop. So when I explained in the normal file system, when you process the data, when you want to process the data, let's assume I have a data center. The data center therein, let's assume it is there in USA or Singapore, some other country. It's a big data center where I have a multiple machines are connected in an NFS file system, and I have stored some data in that. And the same network, I have a client machine, storage area network, where I will actually do a computations. When I connect to this DB by querying something, what it will do, your data will be start traversing towards your client. The data start traversing towards your client, which if it is a huge amount of the data, yes, we really need a high bandwidth. And even if you say it is in the same network, again it has to traverse to the towards the client. It may take some time, and we'll store in this in the main memory of the client, and we'll apply the our computation in here. Again, it will take some time. As I said, here it will take some time, and here also it will take some time. So instead of that, Hadoop says that instead of moving the data, you move your computation. Our computation will be our computation in the sense our logic or our program will be some 1 MB or 2 MB or some KBs. Instead of traversing the GBs of data towards the client, you send 1 MB of computation towards the data and process it there parallelly. As I shown in the previous diagram, the data will be processed parallelly there and it will give the output. So where we are which we are achieving getting the reports or getting the results in a lesser time. Okay, yeah. Here one of our team guy has a doubt. I have doubt 200 MB of data have stored in 3 data nodes 64 remaining 8 MB. Okay, Chandu, I'll come to this point. I'll show you that it really will not take. It will not take other. It will not waste the 55 MB of data. It will be shrink. I'll show you that. We'll look at that. We'll not yet come to that point. Clear about the data locality? Clear about the data locality? Yep. And heterogeneous cluster. When you are making a cluster by using multiple machines, we don't need to have a same kind of machine. It can be any kind of machine. Like, let's assume you have a 4 node cluster, where is one node is the IBM machine which is running on Red Hat Enterprise Linux, and you can have one more machine which is running on the Intel machine with the Ubuntu. You can have other machine with the AMD machine which is running on the Fedora. You can have other machine which is HP. It can be on CentOS. Here you can have a different kind of machines, and you can connect them each other. You don't need to have a same kind of machine. Let's say it has to be the same OS, or it has to be the same processor. Right? There is no that kind of constraint here. Here we can install any type of machine to the cluster. It will be managed, but it has to be a Linux flavor. We'll see whether it will work on Windows or not. We will see that. It will also work on Windows, but how it will work on all we'll look at going forward. When it comes to scalability, here we are achieving the parallel processing. Yes, here we are getting the results in very quicker way, and it's scalable up to horizontally also. When the data is getting grown, you don't need to increase vertically. Yes, vertically also is possible. When the data is huge and our cluster is going to increase, I mean we have to increase the cluster. Yes, correct. I do agree. Vertical scaling also possible here, as well as the horizontal scaling also possible. We can scalable easily without no when the cluster is running and I want to install a new, I want to add a new data node to the cluster. You can go ahead and add. It will not disturb your current work. It will not no, it will not bring down your cluster. It will start continuing. Then once you install a data node to the cluster, you have to do a refresh. How to issue the command and all we'll see in the going forward. Is this features are clear, guys? Any doubts? If anyone has a doubt, please stop me there and then and there and ask me. I'll answer there. Am I clear?
Yes, Ravi.
Yeah. Okay. Yeah. What makes Hadoop really useful? One is scalable, as is explained, where you can go ahead and scale up your horizontal or vertically, and it is economical. You don't need to invest more on replacing the existing system or buying a special hardwares, and it's efficient because the data is getting processed parallelly in the multiple machines, and it's a highly efficient, and it is a reliable as well. If something is failed, you can go ahead and automatically, or you can go ahead and install a new machine, which you can we're not going to lose any data there. You can go ahead and install a new machine to the cluster. The data will be balanced. Okay, and the final, it's not the it's a major one. It's a free open, it's a open source. No need to invest for the software. And what are the list of distributions available? There are so many distributions available in the market, and but the classic version is Hadoop, Apache Hadoop, and Cloudera, Hortonworks, Mapper, and your EMR, Elastic MapReduce from the Amazon. There are Greenplum. There are some other distributions as available in market. What is the difference between the classic version and these Cloudera, Hortonworks, or Mapper, or some other distribution? The main difference is all are open sources. You don't need to pay for uh, installing using the software. You don't need to buy any license. And when it comes to the Apache, you have to install everything manually. Like, as we saw in the ecosystem, we have different kind of tools or different kind of process layers. For the data storing we have different, and data processing we have different tools, and accessing, monitoring, and loading into the cluster, there are different kind of tools. Each and everything you have to install and you have to configure manually. But when it comes to the Cloudera, Hortonworks, and Mapper, they are just plug and play. They're already available in the framework. You need to start them and start using them. If you just, you need to configure according to your requirement. When it comes to the Apache, you have to install everything. You have to set the class paths, and you have to install in each and every machine. We don't have the manager here ideally. When it goes to the Cloudera, we have a Cloudera manager where you can manage whole cluster from one window. And the same way for Hortonworks and Mapper as well. When it comes to the Apache, it is a bit hard to do that. That's the only difference. And if you get any software issues, like something is not processing or some API is not working, that kind of issues, if raised from Apache, we have to fix ourselves, or we have to look for help from some contributors. But when you go with the Cloudera, Hortonworks, or Mapper, or some other Greenplum or Pivot, these distributions, they will support you. They will give support. For that support, they will charge. So when it goes to other distribution, the support is the maintenance and support is the chargeable. When it comes to Apache, we don't get any support. We have to do ourselves, or there will be some communities, community provided, contributor. There are some contributors. They will be solving some problems. So when you raise your issue in that, so they may turn back and they may solve the problem, or you have to invest your time. And what is the ecosystem? Ecosystem is, in HDFS there are collection different type of tools are we have to process different kind of data. And what are them, we'll have a look at it. This diagram shows, so we can store any type of data, as we saw yesterday. Any type of data we can store into the HDFS. If it is the data I want to store from your relational database, which is already available, or it's a legacy system, I can say that from that system you are migrating to Hadoop. You have a tool called Scoop, which will help you to import or export. Like, you can store you can get the data from RDBMS and store into HDFS, or vice versa also possible using Scoop tool. And there are some servers where the data is keep generating. You want to inject the data, whatever the generating the data by those servers, into HDFS. You have a tool called Flow. where the data will be keep injecting into HDFS. And where you want to process, where you want to generate reports, or where you want to query the data, we have a database kind of tool in HDFS which will work on top of HDFS, that is HBase. HBase in an interface, I can say, it will not store any data, but ideally the data is getting stored in HDFS. The data if you want to process some data, we have a MapReduce where it will process the data parallelly on different machines. And where you want a data warehouse kind of system, and we have a Hive tool which just came from Facebook, who developed in Facebook, and they have donated to the Apache. So we have a data warehouse kind of system on Hadoop, that is Hive. And if you want to do some kind of data analysis, or you want to clean up some kind of data, or you are more comfort with the data flow language or scripting language or Latin scripting language, so we have a tool called Pick, which is came from Yahoo. Okay, clear guys? Clear about Hadoop ecosystem? We'll be seeing different kind of layers in ecosystem. If you see, we have a different kind of layers. One is the data storage. So when you want to store the data, we have a HDFS. On top of HBase only will come, but in the diagram it's showing that different layer. Why? Because it is a data storage. It's also an interface which will run on top of. It's also run on top of HDFS only. Your HBase also will run on top of HDFS, which is a columnar database, NoSQL database. We'll look at them in detail. And for the data processing, we have two different kind of process, I can say. One is a MapReduce, which is a Hadoop 1.0 1.x, and there are some flaws in this architecture. So there are some burden in this architecture. They have overcome with the Yarn. Yarn is yet another resource negotiator. We will see this also. We'll see what is the difference between these two. Yarn is a data processing system or data processing layer. When it comes to the access the data, we have a different kind of tools like a Hive. You can access the data through Hive, through Peak, some Mohoth, which is a machine learning. There is Auro format kind of data for serialization, and you have a Scoop to interact with the RDBMS kind of database. To get the data from RDBMS, or you can store the data to RDBMS which is already processed. If you have a limited data, which has less data, after processing you are getting less data, that data you can go ahead and store into RDBMS, because there are some limited applications. There are some applications which will run only on top of RDBMS. So for that kind of things, we can go ahead and use Scoop. And to manage all these data nodes in a cluster, we have a different kind of tool, data management tools. Zookeeper, who will manage the complete cluster. We'll look in detail what is a Zookeeper. And Flume is a monitoring tool. And if you have a Chukwa, it's also kind of a monitoring tool. And not only this, along with this, there are so many tools are available in the market. Like the tool name is I forgot the name. I'll tell that name. Yeah, I'm just starting that.
Flume doesn't come under data access.
Flume, no, did not come under data access. It's just monitoring. Flume, yes, it's a monitoring tool ideally. And you have, if you want job flows, if you want to configure your job flows, we have a Woozy, where you can configure which job has to run first and which job has to run next. We have a Woozy, and we'll see all this detail in one by one detailedly in the coming slides. Okay, just an introduction to all the tools. We'll look into detail one by one. Yeah, this is about ecosystem, what Piggies do, what HBase, and how Hive will work, what Scoop will work, and Flume. We'll be covering part of this course. We'll be covering all this. And how Hadoop works. Hadoop
Ravi,
has,
one question.
yeah.
Ravi, one question. Like import and export
Mhm.
from databases, do you have only scoop? Because I know this is a Flume is for a real data, but for a static database,
Yeah.
you have only scoop available.
Yeah, Scoop is available. Correct. Scoop only available.
Only want to.
I mean, there may be other tools, but I didn't come across them. Scoop is the main
Okay,
tool
okay.
we are using in the current ecosystem.
Oh, okay, okay.
It's the open sources,
And
right? These are the
Ravi,
open
sorry,
sources. There are,
Ravi,
yeah.
Ravi, sorry. Here at this stage, actually, I have one more question.
Mhm.
Like, if you go to last slide where we have scoop, Flume between database, one more, please.
This is the one.
No, other one.
Okay. Okay.
Yeah, this is. So, like here, structured data, like I will consider this as a database.
Hmm.
So here, instead of using scoop,
Hmm.
can't we use our traditional approach? That means actually the scoop is to take the data from database
Okay.
and keep into the HDFS system.
Correct.
Much into the file. That means get the data from database and create the files and load into the HDFS.
Yeah. Okay.
So the, the traditional approach, what I mean is the traditional approach means like if you take some of the mainframe things,
Hmm.
most of the times mainframe also does the same, right? Like if you take the ETL, our regular ETL.
Hmm.
So before the ETL, sometimes we used to use the mainframe jobs, which they get the data from source and create the files, and the files will be sent to the ETL.
Okay.
So, like, what will be the difference between using the scoop method and our regular the method we are following in the industry, like for the regular ETL process?
Okay. So that we'll look into very detailedly, but I'll just give an introduction for this. See
Yeah,
here,
yeah, yeah.
see the data when you want to load from the your traditional database to HDFS, when you go with other
Uh-huh.
tools, you'll not be having the parallel process, parallel way. I mean, parallel you cannot load the data into the HDFS. It will go in the sequence manner. But when it comes to the scoop, it will launch multiple jobs and it will start loading the data into the HDFS.
Okay, that means the performance
Yes.
operation speed is more.
Yes.
Okay.
And when you want to, I don't know about I think as you said the mainframe tool whether it has a capable of storing one table at a time or whole database at a time. But here you can store the part of the data, you can get the part of the data, or you can get the one table, or you can get the combination of the table, or you can store complete database to the HDFS. You have these features in this scope.
Okay. Because normally, like if I see some of the our regular data warehouse tools like maybe data stage or Informatica.
Mhm.
So in most of the cases, what I saw is so there will be some mainframe jobs.
Okay.
So otherwise, some of the Unix jobs which
Okay.
creates data, which creates the files from source, and from there it will be moved to data stage actually. Then that's where data stage will take the files and it will process the data.
Okay. Again, it will taking into RDBMS only, right? It doesn't have it's a HDFS kind of platform over there.
Yes, yeah. Maybe a target set is the different, maybe up to the source, like
Okay.
up to the processing.
Okay.
Like means before one step before the map reduce.
Okay.
Sorry
Here,
guys, sorry to, it seems like discussion going in a different way. Yeah, first of all, everyone try to understand the Hadoop architecture. Then only these kind of discussions everyone can understand. Yeah, I'm sorry, Ram. We will discuss the same questions once everyone understands what is Hadoop, what is Hadoop ecosystem, how all these are integrated together. As of now, it is making confusion to others. Okay, I'm sorry for that. Okay.
Yeah, because
Ravi,
maybe I don't think these are the
like
irrelevant question because
like
so
it is not
when scoop comes into the picture, that's what I raised.
yeah, we'll go in detail. I'll explain the detail how it will work and in the coming slides, Rama.
Okay.
Yeah.
yeah, please
So
bear till the instructor explains in detail way. Like it is only introduction.
introduction for
Okay.
these tools. So what I'm trying to explain here, these are the tools are available to do this thing. So we'll see the detailed explanation for each tool. So why it is different from others and all those things we'll go ahead and going forward we'll see. Yeah, in between for the questions, I'll be giving the small introductions. We'll see in detail. We'll see in the coming slides. In coming classes, we'll have a specific classes for the scope and flow for all these tools. Is fine, Rama? Yeah. Okay. Now, how Hadoop works? Hadoop works in such a way that it has two different components. One is for the data storing, and the other one is the MapReduce. So one is the HDFS. HDFS is for storing the data, and MapReduce is for the processing the data. And we will look at in detail what is the HDFS and MapReduce in coming slides. But just give me a brief description about what is the HDFS. HDFS is a distributed file system, Hadoop distributed file system, where we'll store the data in parallel in multiple machines and distribute across the multiple machines. So when I want to store some amount of data like 1 TB or 10 TB of the data, so when I issue a query or when I issue a command, the data will be broken into pieces and that pieces will be stored into the multiple machines. We'll see HDF architecture, we'll see MapReduce architecture as well. Okay, when you store the data into multiple machines, the parallel processing is possible. The parallel processing will be done by using MapReduce. MapReduce is the tool where we can process the data in parallel way. And even other ecosystem tools like a Hive, HBase or Pig, even those are also will process the data in parallelly, but at backend, ideally it is converting as a MapReduce jobs. We'll see detailedly what is map and what is reduce, to whom it is mapping and why it is where it is reducing. All these phases we'll go ahead and look into when we are covering the MapReduce. Okay, MapReduce is the framework, which is designed. It's a purely Java code, I can say, where it is where you processing the data using Java. Okay, we'll continue with HDFS. We'll see what is the HDFS. Before that, getting into HDFS, we'll try to understand what is a DFS, and we'll look at what is the HDFS and what is the difference between these two, and how it will work. All this we'll be seeing one by one. What is a DFS? Distributed file system, and how it is different from HDFS. We will look in these details. Before that, try to understand what is a DFS. A DFS is a method of, or I can say, the way of storing the data in a multiple machines which are connected into the network, like your NFS file systems, network file systems. In a distributed file system, we'll be having the machines are connected internally each other, and it will working in the fashion of like client server architecture, where client will when you access the data, he will look, even though the data looks like it's shared in the multiple machines, but when it comes to the client side, he looks like it is there in a single storage, single access. There will be that the data will be stored across the multiple machines. When I say across the multiple machines, here the data the whole data will be stored in one machine. Let's assume we have a employee, salary, department, and students. There are different kind of data, and whole employee data will go and sit in one machine. Whole student data will go and sit in other machine, and whole students and department related data will go in different machines. But even though they all are internally connected and where it can be accessible from the client, it looks like a single point where you can access the data. If I want employee data, I can go ahead and access employee data. Even where I want to access the student data, I can go ahead and access the data. Let's assume I want to process employee data. It will be there in a single machine, and it will be processed in that single machine only. I want to process a student data. The data will be there in the one machine where I have to process in that machine only. So there is no parallel process here. I cannot able to process the data parallelly. And other issue is with this, if employee data, wherever the employee data is there, that machine is failed. I don't have the recovery. Right? So to overcome these problems, and we come up with the Hadoop HDFS. Clear, guys? What is the problem with the DFS? The data will be spread across the multiple machines, and the whole data, I can say whole set of files belong to that data will be stored in one machine only. And here, if it is there in a single machine, if its hardware fails, we lose the data. If you want to process the data, I have to wait till it's only one machine, right? So till until it has finishes, I have to wait. So when it comes to the HDFS, okay, we'll see the difference between, in the DFS only, we'll see the difference how it will work. Before DFS, the data will be, it's not internally connected. There are independent machines. If you see the IP addresses, like these are independent machines. This is different machine and this is different machine. All are different machines. When I issue a query, the whole query will be processed in this machine. And if I want to access, I should know where the data is available, right? So when it comes to the distributed manner, there will be single place which can be shared across the network. It's like a global namespace where the global namespace available, we can go ahead and connect and get the access to this. So what is the problem with if it is not distributed, and if it is distributed, how we are achieving the performance? Let's assume you have one machine where you have 1 TB of data, and the data transfer rate is 100 Mbps. You have 4 IO channels. Let's say it's a 4 core machine, and to process 1 TB of data with the speed of 100 Mbps by using 4 channels, how much time it will take? The same data has been spread across the multiple machines in spread across the multiple machines, which has the same transfer rate and it has the same number of channels. I can say processors. Let's see how much time it will take. To process one machine, your 1 TB data in MBs, by dividing into your per second, it's the time taking is coming for 43 minutes for one machine. It's taking 43 minutes for one machine to process 1 TB data. The speed rate is 100 MB with 4 channels. It's 1 MB per second, right? So we're converting it to. Now let's see the same data to process in multiple machines, in 10 machines. So how much time it is taking? So it will be finished by 4 minutes only by 10 machines. Because why we're achieving the less time, why we're achieving this performance? Because the data has been spread across the multiple machines where the process is happening in multiple machines simultaneously. The final output is we're receiving in the very less time. Clear, guys? So difference between the DFS and non-DFS approach.
Yes, Ravi.
Yeah, how the data will be processed in DFS? The data will be processed in DFS. Even though those NFS, ideally it's a network file system, distributed file system. It came NFS is a file system which came from the Microsoft, and how the data will be processed here. Even though the data has been spread across the multiple machines and is managing by one master kind of node. So when I want to process a data, you'll be having a storage network area machine. It's like a client. He has to get the data. He has to talk to all the nodes where the data is available. He will take the data and he will process in a single machine. There is no parallel processing. This is the way the data will get processed in network file system. If any one of the machines failed here, see this slave node 3 contains only specific to employee data, and it contains only specific to students data, or it contains only specific to some XYZ data. So if you want to process employee data, the only one machine has to process it, which may take more time. Then what is HDFS? How it will solve? How the problem gets solved in HDFS? HDFS is a Hadoop distributed file system. What it is? It is on a virtual layer on top of your local file system. In a local file system, your block size is 4 KB. When it comes to the Hadoop distributed file system or HDFS, where you can configure your block size. It can be 64 MB, by default it's a 64 MB, where you can make it 128 MB or 512 MB or higher, bigger than that. Depends on your requirement. In the HDFS, the data will be stored across the multiple machines. How it will store? As I said, the HDFS follows block structure data file system. The data will be stored in the HDFS bigger blocks, not the 4 KB small blocks. In the cluster, the data will be stored with the bigger blocks. And even though underline that local file system, it will be 4 KBs, but when I refer the HDFS block, Hadoop HDFS block, it is the combination of the smaller blocks and it make it as a bigger block, and where you are seeking time and transferring rate is decreased, where you can process a single block at a time with a one processor. But when it goes to the local file system, the small blocks will be there, so each block will be processed by one processor. It will take more time. To reduce the seek time and increase the transfer rate, so Hadoop come up with a different bigger block. You can see 64 MB or 100 MB or 120 MB. You can configure it. You have a control on it. And HDFS uses a commodity hardware where you can store a data, and where you can store huge amount of the data, larger files. With respect of the format of the data, variety of the data you can go ahead and store in HDFS cluster. It doesn't belongs to any schema, I can say. When it goes to traditional approach, the data has to be, will we specify the schema? The data has to be stored like this. But when it comes to the HDFS, there is no specific schema. One block maybe have a 64 MB as a block, one block maybe 100 MB as a block, and one data, I'll say one type of data can be some different kind of data. Let's an example. Let me show you an example. I'm storing in a cluster okay. It is a name node. It is a master node. I'll explain the architecture in detail. It is a data node. Now in this cluster there is a file called employee, which I have stored with a 64 MB block, and I can store how many replications I want. By default, the replication. Why we need a replication? I'll explain that. To data recovery, for the easy when the data node is failure, the data recovery will go with the replication. Let's assume it has the replication factor is 3. But I have other data which is related to stock, and I may not be able. I don't want to process this data very frequently, so I may go with this data block size as 128 MB. But I don't mind. I don't need the reports immediately. I don't require the reports immediately. So it's fine if I get a bit late. Fine, I'm okay with that. To get the reports, if it takes some time, fine. So that cases we can increase your block size, and the block size you can in this cluster you can have a different kind of block sizes. And the replication factor, the data is more important you can go with 5 replications or any number of replications. What I'm trying to explain here, it doesn't require only one specific schema. Like whatever the data comes in cluster, it should be have only one structure, or it should be have only one property, like 64 MB as a block for this, and only three replicas. Whatever the data you store in my cluster, it will be always 64 MB, always 3 blocks. It is not the case where you can store different kind of data and with the different properties, like block can be more, and you can it's in your control. Clear about it? You can store
Okay,
it.
here I have it.
You go ahead, Rama.
So like here earlier you said like let's consider here employee and stock. There are two files coming up actually.
Okay.
So now in one place actually we kept the replication factor as a 5, and one place we have the replication factor of 3.
Correct.
That means while configuring the replication factor, will the replication will go at a file level?
Okay. Yeah. Here we can configure in one file level as well as in the cluster level. Cluster level means for the generic level. So generic level we'll configure in the our configuration files, where we have a configuration files we will specify there. When you want to file specific, when you are loading the data by using your command Hadoop and your FS or the command, right? There you can specify your block size and your replication factor. And
Okay.
this, yeah. Clear, Rama?
Go ahead, Ravi.
Yeah. This data.
That means you mean to say whatever we configured in the configuration file, so that is a default one. That means like if it doesn't give any replication factor for the stock file on the command line here.
Yes.
So that means by default it takes 3 based upon the configuration file.
Configuration file, correct. The blocks based on the configuration it will take, but you want to override that explicitly only for specific this data. So we can go ahead and override that. And you can ask me how it will maintain, because your name node, the metadata will be maintained on the file to block to data node. So there is no problem here to maintain the different kind of sizes or different kind of replications.
Okay, that means it's not necessarily every file should follow. That means by default, everything follow the configured one, but still externally we can change it.
Change it, correct.
Yeah, thanks. Yeah, it's a clear. Yeah.
And clear about that, that's what I'm trying to say here. We don't need to follow the same schema for all the files or all the whatever the data we're storing. Okay, and what is the differences between your HDFS and data distributed file system? Hadoop distributed file system, your distributed file system. As I explained before, here in the HDFS file system, a block is bigger block, and where it comes, it's a smaller block. How it matters? It matters when the data, processing the data, the seeking time and transferring the data rate. And in network file system, all the data belongs to, as I said, all the data belongs to one machine. Let's take complete stock or complete employee data will be in one machine only, and there is no parallel process here. But when it comes to HDFS, to store or to process the data, we have a parallel. Parallelly we can do that. And because of the data is storing in one machine, if that is failed, so we may not be able to recover the data. Because of the data is stored in one machine, it is a sequential process. It's not a parallel process. And your NFS is not a fault tolerant. When it comes to the HDFS, we have a multiple replications of the same data. If even the data node is failed, one of the machine is failed where the data is stored, we can recover it easily without any problem. So we can retrieve from other machines. We can execute the job as well without any problem. While executing the job, while processing the data, one data node is failed, still the job can success. Still the job will go ahead and success. It will not fail the job because the data is not available. It not say that I'll not process the data, because there is a replication factor in other machines. It will go ahead and process that data and it will give you the results. The same data is available on multiple machines. Clear? Yeah. When it comes to the architecture, the HDFS architecture looks like this. It follows master and slave architecture. What is the master and what is the slaves? What are their roles and responsibilities? We will look into the coming slides. Here the master is your name node who will maintain the meta information about the data. I can say metadata about your data. Your name node is responsible for give, maintaining the cluster. I can say it is responsible for identifying who are all alive and who are all storing what kind of data and whether he is processing any data or not, whether he's alive or not. How he will come to know? He will come to know by heartbeats. We'll say it is a heartbeats. The heartbeat is every 3 seconds. The data node will report to the name node saying that I am alive. It will send some report to the name node saying that I am alive. I have this much data in my machines and I'm processing currently this. This kind of report data will be sent to your name node. And your name node is responsible for assigning the task to process, or your name node is responsible for assigning the task to your data nodes. Data nodes are the slave nodes where the actual data will store, where the actual data is there in it. So when you want to store a data into your cluster, first your name node is the only intermediate. I can say he is the only person who can you contact. You don't know what are the data nodes are available in the cluster. We never interact with the cluster directly. We never interact with the data nodes directly without name node intervention. So name node should be there. If you know the name node, then only you can talk to the data nodes. Let's take a simple example. I want to write a small file into our cluster. I want to store as employee data or stock data into cluster. Then my client machine, when I issue a command, it will talk to a name node saying that this is the file I want to store in cluster. This is my replication factor and this is my block size. Your job client will tell to the name node. Job client means where your command is executing, where you are logged in, and it can be a remote machine or it can be one of the data node machine or it can be an external machine from out of the cluster. So he will talk to the name node and name node will have the report and he'll be knowing, right, which are the data nodes are free, how much space is available in that, which are the data nodes are processing what kind of data. So file to block and block to data node, the mapping is already available in the name node's memory. And your name node look at the metadata according to that, and according to there is one more policy called block replacement policy. It will look at taking consider all these things and it will give these are the data nodes list to our client. Will client receives a data nodes like list of data nodes in a sorting order based on the distance. Based on the distance, it will give to the client. It will be sorted and it will give to the client. Then your client will start interact with the data node directly. It will create a pipeline where a file IO channels will be created, and it will start storing the data. Who is storing the data? The data is getting stored in the data nodes, which is sent by client. Without interacting with the name node, the client never know where all the data nodes are available and what are their status. He never know. We cannot even interact with directly the data nodes. We cannot store data directly into the data nodes. We have to talk to the name node, and name node will give the details here and all. You can go ahead and store, and the client will start storing the data into those machines. Okay, the communication channels between your name node to data node is RPC call, which is remote procedure calls, and the communication between data node to data node is HTTP. The communication between your client to data node is again HTTP. And in the architecture, we are missing one more component called secondary name node. And without that secondary name node also, our cluster will work successfully. That is the why this architecture is explaining here without a secondary name node. So secondary name node, if you really worried about the data or backup and all, we can go ahead and configure it. We'll see them in detail. We'll see detailedly what is the name node and what is the data node and what are the what is the purpose of them, and what is the secondary name node, what is the use of the secondary name node. All the details we will look into one by one detailedly. We have a separate slides for them, and to explain each and every functionality, how they are maintaining the how they are maintaining the metadata, how they are storing the data, where and all the data is storing, what is the which is the format it is storing. Everything we'll go ahead and look into the detailedly the coming slides. If this architecture is clear, it is a master slave architecture, where is a master is a name, where is your master is a name node, and where is your slave node, slave is your data node. Okay, here I'm not talking about the processing the data. I'm just talking about HDFS. HDFS is meant for the storing the data. I'm talking about only storing daemons. I can say storing architecture, HDFS architecture. The name node is a master and data node is a slave. And when it comes to the process also will follow the same structure, same architecture. I can say the master will be job tracker and your slave will be task tracker. The job tracker will be running on the name nodes machine, and your task tracker will be running on the data node machines. So we will look them into detailing. What is the job tracker? What are the roles and responsibility he has? What is the task tracker? And what are the roles and responsibility he has? All the details we'll be looking at. Okay, how to write the data, how it will store the data, how it will divide the blocks and all. We're going to look at in for following slides. Is this clear, guys, about the HDFS architecture? And
Ravi, here one question.
Yeah, go ahead, Rama.
Ravi, here, do you have any specific channel between client and name node, like RPC and HTTP?
Client and name node. It's the RPC
Name
call,
node.
Ram. RPC call.
That also RPC?
That is
Okay.
also RPC.
So, okay. Two RPCs, one HTTP. Okay. Yeah.
Yes. Yeah.
Next one.
Okay. So here the daemons will come into picture. Daemon services. Okay. 1 second, guys. It's already. Before going to this slide, let me check with your availability. It's already 7:30. If anyone in India time it's 7:30, and you might have 9:30 or 10 o'clock in the evening. Shall we go ahead and continue, or we can stop the class here and we'll continue tomorrow? Guys, could you please respond? Shall we go ahead and continue, or shall we stop the class? Continue tomorrow. Okay. What about other guys?
We'll continue tomorrow.
Okay. Okay. Yeah. Fine, guys. Then I think majority of the people wants to continue tomorrow because it's already more than 1 hour session. It may be overloaded with multiple things.
Yeah.
Yeah. Thank you, guys.
Thanks,
Thank you,
Ravi.
Ravi.
Yeah. Thank you. If anyone has any doubts, they can stay back and ask me. If anyone, yeah, okay, I forgot it.